Hello, I am Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today, we are moving on to the third of the 5 elements of software modular design. Encapsulation is the topic du jour, and it is the middle of the 5 elements as I'm listing them, and it is kind of the central element. It's kind of the whole point of modules in the first place, is we are going to be separating the interface from the outside. The interface is going to focus outside, and the implementation is going to be hidden inside via encapsulation. The element associated with encapsulation is water. And my reasoning here I think is pretty clear. We want to make the module as watertight as possible. We want as little leaks as possible. So although all abstractions are leaky, some are more leaky than others, and we want to make our module as leakless as possible. And this practice of mastery along this bit of fun is learning how to control water. So why encapsulation? So strong encapsulation is nearly watertight, and that empowers you to move fast. It allows you to make changes without fear of breaking things, because anything on the inside of your module, as long as it passes the tests set against your API, you know that all your clients are going to just work because you have strong encapsulation. So the inside of your module is very separated from the outside. On the other hand, if you've got a weak encapsulation, a leaky abstraction, then it's going to grind your productivity to a halt. It's going to destroy all modular complexity leverage. And here's that key thing again, that key idea of leverage. So we're going to, whole point of doing a module to manage complexity, so we're going to take a huge chunk of code and we're going to put it behind a comparatively smaller interface. Maybe the interface is like 1/100th the size of the overall set of code. And if we have strong encapsulation, then the clients of that interface really are only dealing with a small chunk of code, and therefore it's become much simpler because this big chunk of code is now hidden and basically irrelevant to the clients. But if you've got weak encapsulation and it's very leaky, then you're really not putting any protection between your different parts of your code, between the module and the clients using your module. So you've really you've got no advantage anymore. You have no more leverage. And worse, because you put this extra pseudo layer of modules, pseudo in the sense now that you're not really doing a module, you have this really weak encapsulation, you actually might have made things worse. You actually might have made your whole solution more complicated than if you'd never done a module in the first place. So let's take a look. What does it mean to have a leak in your module? So broadly speaking, our goal here is to make it so that changes to the module that are assumed, let me back up there. So a leak is when you make changes to a module that you assume are non-breaking, but it actually breaks clients. That's one aspect of leaks. And so these changes. So if you somehow change the inputs that you are allowing, and so that some inputs you allowed previously no longer work, and you didn't realize that these changes were going to restrict your inputs, then clients are going to break. Same thing if you have different outputs for the same input. So given some inputs to your module, it should always return the same expected outputs. And if you break that contract, then you're going to have a leaky abstraction. There's this aspect of the unexpected. And these are all these things that as a client of the interface, you have a certain expectation given the document and the API. And if its behavior is undefined, so it's some aspect of its behavior is not even clear from the API what it's going to do, if the outputs don't match what you expect after reading the API doc, obviously if you have any bugs, which kind of results in all these things, and also if you have any unexpected, unpredictable state changes. So if you are either state just changes randomly, state changes due to events that you're not aware about, or you make one interface call and then other state updates in ways you didn't expect. These are all aspects of a leaky abstraction. I think that I had a couple of examples here. So yes, unexpected outputs. When you're doing floating point math, you might add 2 simple things like 0.1 and 0.34 Well, the result is actually 0.44, a bunch of zeros and a 6, because you're doing floating point math, and floating point math can't precisely represent decimal fractions. So that's a leaky abstraction. That's common. Also, other types of unexpected state changes are triggered by async events, triggered by unrelated sections of code, triggers even between modules. All these things where state changes unpredictably are going to be leaky aspects of a leaky abstraction. Last, performance. And so if you as a client are expecting this module to be able to do certain things in a reasonable amount of time, and then you do an update because there's some changes to the module, and all of a sudden certain things become much slower than they once were, that's going to break you. That is, now the implementation has leaked out. And there's the unpredictable performance aspect, which is really to say it's okay to have unpredictable performance as long as you are clear about it in your API and you say there's going to be unpredictable performance here. But if the client is expecting predictable performance and then it becomes unpredictable, that's also going to be very problematic. And all of these kind of belie the main thing that as a client, one should not be able to detect any of the changes that are happening internally. And you should be able to make as many changes internally as you can without the client being able to detect that anything's changed. Otherwise, and here's kind of the key concept I offer, leaks become accidental hidden parts of the public API. So any of these things that are leaks in your encapsulation, ways that changes in your implementation or behaviors which are not defined at the API level that can be detected outside of the module in some way or another, those are leaky aspects of the API. They're actually part of the API. They're part of the interface with the outside world because they're interacting and interfering with the outside world. Ooh, that was fun. So we want to make instead these watertight, leak-proof, strongly encapsulated modules. So our goal is that any implementation detail should be changeable without affecting any client. The explicit API should be the whole API. So the API as documented, however you're documenting your API, should be everything the client needs to know, and there shouldn't be any surprises. And to do this, the first big strategy is to install what I just came up with for this presentation, install valves at every interface point. I'm trying to really milk this water metaphor. But a valve kind of makes a certain amount of sense. So I defined a valve as a code point in your interface between the outside world and the inside world that can run arbitrary code over all inputs and outputs going through that code point. And usually this might be a function or a method or some aspect of the interface of your app. But critically, it means you should never allow direct access to data. You should not allow the outside world to directly modify or read data because that's not a code point. You can't put arbitrary code around reading or writing that data. And as an example, Ruby actually has this really well built in. In Ruby, all interactions with an object from outside the object is done through messages. You're not actually allowed to do anything else unless you would engage some special hacking modes, but all of the standard interactions are done through what's called our messages. Even the things that look like reading and writing just values are actually accessors. They're always accessors. Ruby does not allow you to do anything but accessors. So you can never access private member variables from the outside. Further, you can also implement things like missing method. The missing method handles when someone sends a message that the object doesn't support. It allows you to, again, insert arbitrary code around any inputs or outputs to the interface. That is how you can empower yourself to be able to make any changes at all to the interior of your module without affecting the exterior, because you can put these valves around the input and outputs, and you can filter everything so that any changes on the interior can be adapted to be consistent from the exterior's perspective. And then once you've done that and you put valves around all the well-defined I/O points, then you want to caulk, epoxy, superglue, weld everything else watertight. I'm really milking it here. And really, you want to not expose or share with anyone your internal data types, your internal data structure, your algorithms, your dependencies. All of those things should be 100% private and no one else should know that they exist, including other like pure modules. Like maybe you got two different modules and they both deal with similar data. Well, they should never share data. Module has exclusive property rights to all of the data in that module. So one terrible example of this, I was just talking to a colleague today, is he was reviewing a system, a service, a set of services that were APIs, I presume. I don't know the full detail, but they were both running against the same database in the back end. And that just has all kinds of problems because the data in that database could get modified from one service, and then the other service would be surprised that the data changed. And it just creates all kinds of mess when a module no longer owns its data and other things can come in and change it arbitrarily. That is an extremely leaky abstraction. So at that point, 100% of all access must go through the well-defined API. You also want to document your API well, because part of leaks are really defined in terms of abstraction, in terms of the expectations of the client. And some of that comes through documentation. It's not through just the strict typing requirements of your inputs and outputs and what functions are legal. For example, you really should talk about your performance, at least where it matters in your module, and where you have guarantees and where you don't have guarantees, what your big O is. So as the data scales, how will the computation scale? Is there async things that you're interacting with in this module, in which case you do a request and the response will come back sometime later? Are there other aspects of performance that are going to be unpredictable? You want to highlight all these as part of your API description so that the clients know what they are, and instead of being a leak, it becomes a well-defined part of the API. The other thing you would do is you want to be extremely clear about how state changes work with your module, because surprise state changes are one of the biggest ways that the module can be leaky. And it also is a way that you can be very limited in your ability to change your internal structure because you'll change the pattern of state changes because you didn't document them well in the first place. Instead, define in your API definition how state can change as clearly as possible, all the ways that it can change and also all the ways that it explicitly can't change. And it might be reasonable that there might be a small gap between those two things because we're dealing with the infinities of code, but you want to get both of those as well defined as possible, and of course they should be mutually exclusive. Last, definitely use semantic versioning, but the most important thing is be very careful and very consistent and very accurate about your semantic versioning. Major changes means a breaking change, and minor means you can upgrade to it without breaking anything, but you can't downgrade away from it without breaking things. And then of course, patch changes should be entirely internal. They should be basically inside the encapsulation. They should not affect the external interface. So, in conclusion, the takeaways are pretty straightforward. Strong encapsulation is all about making watertight modules, or nearly, since you can't actually do it perfectly. And as such, you want to have the maximum freedom to change the implementation arbitrarily without affecting clients. And this is one of these paths to mastery that you will get better and better at this over time. It's not something that you can just do perfectly. You can always do better. And when you do that, then you will be able to rapidly evolve and improve your modules worry-free. As long as your module passed its own tests, all the clients are going to be fine. And that gives you so much superpowers with managing complexity. On the other hand, if you have weak encapsulation and your module is leaky, then those leaks become accidental hidden parts of the public API. Not only does your public API get bigger, but it's hidden in secret and unpredictable ways, which actually potentially makes it even worse than if you've never did a module in the first place. So you will be afraid to touch anything at that point for fear of breaking things, and your productivity will screech to a halt and your code will calcify. Unfortunately, I have to admit I've been there, and it is a terrifying position to be afraid to touch any piece of code in your system for fear of it breaking because of poor, weak encapsulation across your whole system. So once again, thank you so much for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.